Hi, everybody. I'm Dennis, and I'm going to try in the next 20 minutes to give you a different take on AI. I think we have about, I don't know, 70% of the talks here are about AI, -2, I'm sorry. But I'm trying to look at it from a more scientific angle. That sounds boring. I hope to not make it boring. And look at what we really have in terms of empirical evidence at the moment. This being said, at the moment, it's a bit like the Wild Wild West. So there is no 30-year in the making consensus on how to do this right. So it's all going to be a little bit preliminary, and I think it's going to upset some people here. That's what I'm hoping for. Okay, let's dig in. So the question is, how does AI help make developers more productive? And we do have a lot of evidence that this is good, that it helps. This is the latest, came out in September this year. DORA is a study that is done by Google. About 5,000 people answered the questionnaires, and more than 80% of these people said that AI helps me being more productive. Only 5% said, no, it's decreasing my productivity. So this is the good stuff, but you know where there's good, there's also bad. In July, we had a study from the independent research, let's say think tank, Meta, and their study made a lot of headlines. Who has heard of it? Okay, half, I'd say. And the headline was, AI slows experienced developers down. So of course, counterintuitive research is always nice because it gets headlines. But it put really a dampening effect on the AI hype. And it got even worse. 9 days later, Jason Lemkin, a very famous software as a service founder, and he runs a large conference system that is very famous in my old bubble, in the software as a service bubble. He thought vibe coding is a good idea. He is not a technical person. And he managed to delete his entire production database with all his client data in it. And with he meant Replit. So his vibe coding turned into wipe coding. And this also didn't really help putting positive emotions into that. So we are at the point where we already have magazines like The Economist telling us the hype cycle is now there where we don't want to be, in the trough of disillusionment. So we have this roller coaster ride going down from the peak of inflated expectations and adjust in this phase where we go down here. And the question is, are we really? Because we also might be here somewhere, let me see if I get this right, on this really slow slope up to the enlightenment phase, and maybe we are just a bit jittering around here and don't know where we are. And this question, I'm going to try to shed a little bit of light on it in the next minutes. And for that, we're going to do something really exciting. We're going to do good old rigorous research. And let's see what we can take away from this. Basically, we're going to look at some studies. There are not many, especially if you look at the ones that are done with a bit of rigor. And we have to have one concept in mind that also maybe is not fun, but it's necessary, and that's the concept of p-values. Who knows about this concept? Okay, that's a lot, that's good. Basically, p-values tell you how sure you can be that your research is valid. The smaller it is, the better. Like always, XKCD has the best expertise on it, and everything below 0.05 is nice, because it tells you it might be valid. Everything below 0.1 is still nice-ish, could be valid in certain circumstances, and every number above this may be a problem for your research. Okay, I'm telling you a lot of stuff, but why should you believe me? I mean, I did not create any cool ego shooter, some very uncool ones, and I did also not create a very famous programming language. So why should you even listen to me? So I've been doing this for a long time. I'm old. So in 1985, this was how I would like to have looked. Yeah, that 8-year-old boy with the Night Industries 2000 behind him, somewhere in the American desert, fighting injustice. And my parents gifted me a Schneider CPC 464 for my 8th birthday. It had 5,000 bytes more RAM than the C64, which I'm still proud of. And I wanted to use it to build cool stuff. So I'm not interested in code as the end of all games. I'm interested in code as a means to an end. And I tried to build a racing game that worked in 3D with the Night Industries 2000, and I learned very quickly that 3D graphics is hard and gave up on this. Many years later, I worked at a research institute for 3.5 years and had kind of a brainwashing experience there. My professor was a very rigorous man is a very rigorous man who taught a lot about looking really at the data when you look at research. So since then, I'm not fun at parties anymore because I always peek at the data and tell the people that everything they did is maybe not as good as they thought. After that, I spent 15 years in a startup that I founded with friends. I worked mainly in the machine learning data science area, so I also have a bit of experience regarding all the hype cycles that are happening there. We sold this in the end of 2023, and after a slight crisis of conscience, I can now be a nerd again, which I really enjoy. Since about 1 year, I'm a professor of applied computer science at FH Wedel. Who here is from FH Wedel or has studied there? Nice, hi. I really enjoy, I can teach programming there, it's really fun. And I also do a little bit of research. And this research happens to be on the topic of how does AI impact software businesses. So basically, the next 13 minutes I have left, I will present you this. So let's start with the controversial study first, the meta study. The meta study did something very clever that the other studies before didn't. They asked a lot of people before how they think developers would be impacted by AI. So you can basically see the 5 dots here, 4 green ones and a red one. The green ones were the people who were asked if AI is beneficial. So economists are really dangerous people, and they thought, okay, developers are sped up by 40% using AI. Then they asked machine learning experts, even more dangerous people, and they said, yeah, it's going to be 38%. And then they asked the developers themselves, the ones in the study. And they asked them twice, before, and before they said, okay, I'm going to be 22% better. And afterwards, when they did the task, they asked them again. And they said, yeah, that was fine, actually. I was 20% faster. But what they also did is they measured the time by screen recording. And it turned out they actually were 20% slower. So this is an interesting finding, right? Because it's completely the opposite of what everybody has expected. But does that mean now that AI is useless for coding? Let's look at some other data. We had some studies. So the first really, let's say, more popular study, I don't know if you heard of it, is the so-called GitHub Copilot study. I will call it Peng 2023 because it sounds nice and it's also the first author. They used a very early version of GitHub Copilot, the first one with the GPT in it, and asked 95 people to implement a very simple HTTP server in JavaScript. So it's an easy task. And as you can see from the figure on the left, that the blue bars are the times people used when they used AI, and the orange bars is the time that people needed when they didn't use AI. And without any statistical details here, you can see that the blue bars are closer to the left, and the left is where less time is. So this study found a 56% in reduction in time to completion for this task. This also made headlines because it was the first study that widely showed that AI speeds you up. The second one is what I call Paradis 2024. It's from Google, so it's a study within Google. They asked about 100 Googlers to complete let's say, Google type tasks, but they were synthetic, but they were a bit more complex than the one from the Peng study. And they chose to report it in a bit different way, but I mean, you can also see here, this is what we call box plots. And you can see that the top one, this is the one where AI was used, is also a little bit more to the left, which means they took less time. In this case, between, I think, 22 to 25% less time. So we have a second study that confirmed the effect that you can be faster using AI. And then we have a very recent one here. This one I really like a lot. It's not as popular as the others, but it does one thing quite differently. It has not 100 or 95 developers in it. It's 5,000. So they did an actual field experiment here. And they had people at Microsoft, Accenture, and another company that didn't want to be named to do a lot of tasks between 5,000 developers over months of time. And what they did is they used a lot of clever statistics. You see that with the fancy letters like DID, WIV, that are all like complex versions of ordinary least squares regressions that you use to pool data when you have different data sources. It's actually very sound, very rigorous. And in the end, they came to this number 26.08, which is also the reduction in average time to complete a task when using AI instead of not using AI. So they confirmed basically the previous studies and said, okay, now we worked this through with 5,000 people, and we still are 25 to 26% faster. They also did a second thing, and this is the small stuff I can see here, but it must be somewhere around here. They looked at the seniority of the developers. So they had them fill out a second questionnaire with some additional data. And in this study, they realized that the more senior person didn't have quite the same speed up. The speed up was less. This is the finding that was also in the Peng study in 2023, where they also found that if you are more senior, you do not profit as much as you did when you are maybe a bit more junior. So we have 3 studies that say it's better and 1 that says it's worse. Unfortunately, the meta one is the newest one. But I do have some observations here, and this is where I get a bit nitpicky and not fun at parties, that I want to share with you about this. So one thing that really strikes me, and I have not found a good argument why this is a good thing, in the study there were exactly 16 developers. This is not a large number. This is about, I don't know, 3% of what is sitting here at the moment. And because it was only 16, they did report, buried very deep in the appendix, on the second to large page of this very long paper, this chart here. This chart shows the effect for every single developer in this study, but 1, because I don't know, developer 16 did not make it to that chart. And what you can see here is that actually 4 of them got sped up and only 11 of them got slowed down. And there's a funny thing that's called binomial test. So when you just take this fact and say, okay, I have 15 people, 4 got sped up, 11 got slowed down, is this something that is significantly different from randomness? And it turns out it's not, at the 5% level at least. So that would, for me as a reviewer of that paper, would have been a thing where I would have said, okay, maybe this is not something I would publish. Also, you look at these things that look a bit like TIE fighters, right? These dots with the bars. And these are actually confidence intervals, which means the bars, the whiskers, depict like the range where we probably think that the effect is in. And if you look closely here, you see that all of these bars cross the 0 line. But the bar for developer 8 doesn't by a hair, let's say. This means for all the developers, statistically, we are not sure if this is a positive or negative effect. It could very well be an artifact. I think they should have put this in the paper and not in the appendix on page 57. And another thing, and this is something that's maybe a bit more debatable, that's maybe more a subjective thing by me, is that this is a very specific setup. So they have extremely complex tasks. They chose the most common repositories, which a lot of stars with, some of them are 30 years old, some of them have 8 million lines of code. So you can imagine major code base, little changes that take a long time, a lot of risk for you if you send the PR that is stupid, because your reputation gets really a ding. And they only choose to recruit very senior devs that have at least 2.5 years experience in the repo before they let them go into the study. So we have a subset of the developer market, let's say, where we have very experienced people working on very, very, very major code. And also, and this is also buried on the last page of the study, they paid them $150 per hour. They wanted to measure speed up. So there is a sentence that says, oh, we don't think that is a problem. I do. So they could have very well just paid everybody the same for the study participation, and then the incentive would have been fine. I don't know why they didn't. But, I mean, normally they do this work for free. It's open source work. So if I get paid $150 per hour, I might not be inclined to be that much in a hurry. So to be a bit provocative here, I think it's a valid study. I will go into that why. But I think the title should have been more like this. It's the effect of AI assistance on developer productivity in very complex code bases with senior level participants that are highly context educated and are paid by the hour. So I'm pretty sure it would not have made that much headlines with that title. There is one thing in there that is really great though, and that is that it, for the first time, has evidence that people are way overestimating the benefits of this new tool. So there's actually the first takeaway for you. As an engineering manager, as an engineering professional, you should always trust but verify, which means if all your developers tell you it's great working with AI, you should find ways to actually measure the wall clock time of this. This is a great finding of the study, and I think that alone leads to it having a lot of merit. They also do concede, and they will publish a follow-up. It's not out yet. I waited every day for it, because they didn't use the latest models. They stopped at, I think, Sonnet 3.7. So they have a follow-up with Sonnet 4 and GPT-4, 5 and all that. And they give a bit of a glimpse that they say, okay, maybe then that changed. And even with the complex repos, it's still better. But the data is not there, so we cannot say anything about it. So what can we take away from this? If we put all the 4 studies in a graph, we see basically that we have, like a downward slope. But this downward slope is not because it's gotten worse, in my opinion. It's because we control for more variables and we get more complex all the time. And this is where, for me, the takeaway comes. So we have empirical evidence that this more senior a developer is, the less they are helped in speeding up their coding progress. We have direct evidence from 2 studies. That's the 2 down arrows at the studies. And we have evidence from the sequence of the studies. Because the studies on the left have like a lowish seniority or like a variation, while the study on the right, the meta study, has no variation. It's always very high. The same goes for task complexity. Task complexity. The first one is a very simple task. The second and third study has a bit more complex, but not too complex task. And the last study has an outrageously complex task. So, and this is my conclusion here, if you look at the graph and the way the studies are staggeringly increasing the complexity, there is a bit of a hint that AI may help you less if the tasks get more complex. The same with the third factor, the experience with the code base. In the first study, there was no experience with the code base because they were just hired on Upwork to do this task. While in contrast, on the fourth study, they had at least 3 years in this exact code base. So Also here my takeaway is that the less experience you have with the code base you're going to tackle, the better AI is for you at the moment. This is something that I also can corroborate from my personal experience and also from my experience with my colleagues and my students and other people in the industry I talk to. It's great if you want to get like a new code base up to speed. Okay, I have 5 seconds, that's great. Basically, this is the takeaway, but I want to finish with a very stupid analogy about self-driving cars. So in my view, at the moment, we are at that point. Self-driving cars, and this is the analogy for AI, I'm not talking about self-driving cars here, can be really useful if you just learned how to drive and you are in San Francisco for the first time. Because then taking a Waymo might bring you quicker to your destination as driving yourself. But if you're a pro on a racetrack driving a rally car and you know the car and the track for years, AI might not bring you there faster. Okay, thanks everybody. That's the end.